Alright, greetings everybody. This is Jay Helix again, continuing our series with the LT4 Supercharger install for my L83 Gen 5 pickup truck. In this video we're going to kind of go over the basic file structure I have for my tunes that I like to use to help get myself organized. And also we're going to just go into what I did for the first bass tune. I figured while I was waiting for my parts to still come in for the actual install, I might as well go ahead and download the as found file that I have on my truck, and then start working on getting a bass file set up. So why don't we go ahead and start in with kind of the hierarchy I got set up for directories. When you download HP Tuners, I think it sets up a file hierarchy somewhere, a directory hierarchy structure somewhere on your computer. Just to make things simple for me on my desktop, I just created an HP Tuners directory where I keep all my tunes and my logs. And then we're going to go into the tunes first. So I structure everything based off the vehicle I'm working on. So like I said earlier, I have a 2016 GMC Sierra all-terrain, which is the SLT with extra features for the all-terrain, Gen 5. So we'll go into that guy. And these are basically the different projects that I have for the truck. And then sometimes in the directories you'll see a README in here. This is just a note pad text file that where I keep some basic notes. So I'll go ahead and just open this guy up. Just some information here that I reference during the process. So for this project we're going to be focusing on the LT4 Supercharger. And as I mentioned in the other videos, I have two phases for this project. The first phase that we're going to be focusing on in this series is the actual supercharger install itself, with a stock fuel system and the tune. Later on in the next phase, once I get everything tuned and I've been accustomed to having the install finished for a while, we'll work on upgrading the fuel system. But for now, we'll jump into phase one. So how I have these things structured, and like I said, I'm just sharing what I do. You know, everybody's got their own system. You can do things differently, but hopefully this kind of helps for folks out there just getting started, or maybe some new ideas for the folks that have been doing this for a while. So the way that I like to set up my tuning, I base it off of this book here that I referenced in some videos previously. So like I mentioned in those previous videos, I really like this Master EFI Tuner book, and he kind of put some governance around Dan's tuning process. And for the most part, I kind of follow that for a little bit. But the very first thing, step one, is downloading the as found file off my truck. And the purpose for this file is, like I said, to not edit it. It's the file that you copied onto your computer here, and you're going to use that as a reference. So the file I have on here is based off the last tune I did on the truck, when I did some basic bolt-ons like cold air intake and the headers and the spark plugs and wires that we talked about in the intro and one of the other videos. So again, purpose of this file is to be a copy for you to reference if you ever need to go back to it. So you don't want to edit this file. I mean, you will be editing this file, but you'll be saving it as a different name. So the next step is step 2 here, and so how I like to do file names is up to how you want to do it, but the most important thing for me is having a date in here. Sometimes it may be like a version 1, version 2. So if you change something on the same day, you know what the latest one is. But I really like to have the date in the file name itself. Obviously Windows will give you, if you have it in this view here, it will tell you a date, but that date can change. For example, I was using a different computer to do my tunes on, and when I decided to switch over to a different computer and I copied all the files over, this date modified obviously got changed to the date that I actually copied the files. If I wanted to had this the actual file name with the date in it, I wanted to know the real date that I made the modifications. If I wanted to go back and reference that and know which one was the newest on a certain date, or even when I did it, I would have lost that. So having that in there at least is pretty important. So what this is referring to, so this base configuration changes, these are basically the changes I need to make. I need to update to my truck's current as found to account for the changes we're making with LT4. So why don't we go ahead and bring that file up. So let's go ahead and open that. Actually, I think what I'm going to do is I'll open up the as found file and we'll compare it to the changes I made for the configuration changes. So we'll just drill back down here. So again, we're just walking through the file structure that I've set up. We're doing phase 1, we're in phase step 2. Oops, sorry, actually, we want to first pull up this as found file. And then what we're going to do is use HP Tuner's compare feature to compare it to the file that I modified. And the reason we're going to make those modifications is because of there's the throttle body is getting changed out, and the intake manifold is obviously getting changed. So we have to tell the ECM, make it aware of those changes, because those are parameters that it uses to make decisions. And if we want to have that in there, it would make things a little bit more difficult. All right. So we got the as found file pulled up here. So let's go ahead and compare that to the changes that I made. So that's going to be in step 2. And it's this file here. And this will allow you to see all the differences. And like it said in the file name, it's mainly going to be this airflow here. Okay. So what I know from the file name is out of all these tabs, I only modified things in the airflow. So the first one here being general. So I updated the map sensor. So like with the LT4 map sensor, whether that's the stock LT4 or a different aftermarket map sensor you purchase, I needed to account for that because you can see here on my L83, the max is 105 kPa, but for the 4-bar LT4 OEM map sensor, that guy goes up to 180. And same with the map sensor linear characteristics, 128 kPa. So I needed to account for that for the 425. You might be asking, where did I get these values from? Some of you, it might be pretty obvious. But what I did is, so if you are a registered user of HP Tuners, you can utilize the HP Tuners repository. So what I did is I created a new file, or a new directory called HP Tuners repository. So I logged into HP Tuners, went to the repository inside my account, and I downloaded some stock files. So I pretty much from 2015, I think even beyond 2016, there's not going to be too much difference in the intake manifold and some other stuff in terms of volume and the area of the throttle plate. But I try to find the closest gear and setup that I have. So I did find one here for stock 2015 Z06. That one's a manual. I did find 2 of them that were for 2016. So one was for the standard Z06, and the other one was the premium. For the most part, for what I needed, they were the same. Let's see what notes I have in here. Okay, yeah, so here's the differences between those two. So this is where I based where I got my values from, was from these stock files. So basically what I did was I took my HP Tuners, the editor, I had my as found file, and I loaded up one of the stock files here, and did the same thing we're doing right now. I used a compare and went through each one of these and modified what I needed. So one thing I found that I needed to change was the map, the estimation of the characteristics. Doesn't look like I changed anything in here in the dynamic. And again, I might have to come back here later on and make changes, but for now, this is just kind of getting a baseline set up. So the speed density, this is a big one that to keep in mind that I definitely need to change. The reason being is with the L83 stock intake manifold, this is the volume of that. Since we are taking off the L83 intake manifold and replacing that with the LT4, I need to make sure I update the volume. And for the LT4, its stock LT4 volume is this, so I modified that guy. So moving over to the throttle. For the throttle, so obviously the other thing I did was I purchased an LT4 throttle body that's 87 millimeters, as we covered them on the other videos. So I needed to change the area of that throttle plate. So you can see here on my L83, I got this value for an area, and you can see what the 7 millimeters difference makes in terms of area. Right, let's see what else do we do here. Do anything else for any of these others, and just to make sure, go through these other tabs here. I know I didn't modify them because I would have made note of that in the file name. But yeah, so alright, so that is pretty much it for the base file. So once again, the base file is just those base configurations, like the intake manifold volume, the area of the larger throttle plate, and the map sensor. Let's see, so go ahead and close that. Let's go back to our structure here, and let's go back to our base configuration. So that covers what changes I made there. So I went ahead and saved those changes and named it this one. So moving on to step 3. So I wanted to I need to have initial start tune created, so to be on the safe side after I get everything installed. Coolant is filled in the heat exchanger system, and I'm ready to start the truck. I need to, being that I am consuming much more air due to the supercharger and larger throttle body and all that fun stuff, that's going to cause a lean condition, and I definitely don't want to. I want to eliminate as much knock as I can. That way I do not destroy the engine. So decided, that's something I can go ahead and do now. So I went ahead and started to make those changes. So the first thing I did here was, so again with GMs, they, unlike Ford and Chrysler Dodge that utilize one or the other, whether that's a MAP or a MAF, GM utilizes both. They use a MAF and MAP. So we need to keep that in mind when we're making our changes. So the first thing I did here was I added 25%. So basically my goal here with this initial start file is I want to add more fuel, and I also want to take out timing to reduce the chances of having a lean condition and causing knock, until I can at least then start the actual tuning process. So keeping things safe. So the first thing I did here was I removed 5 degrees of spark timing and added 25% to my MAF curve, and I'll show you how I did that. So we will go ahead and open up this as found again. as if I was doing it all over again. Alright, so for the first change here, removing the spark, we'll go ahead and we'll do that one first. So I did this to my high octane table, and it's pretty simple. So some loads here. So I wanted to reduce everything in here by 5 degrees, over the entire range. So I up here in the left hand corner, just hit that, just select everything, and then use -5, and we're going to add that, and that reduces everything in this table by 5 degrees. So that's where I decided to start off with, was 5 degrees. So the other thing I did was on my MAF curve, I added 25% fuel to that. So we're going to do that here in the airflow, in the general. Airflow versus frequency is the main table that I use. And so we wanted to add 25% to that. Again, this is just a rough estimate, but it's going to be 1.25. We're going to highlight everything, and then we're going to multiply it. So it's going to raise this entire curve over this entire range up 25%. So when the ECM decides it's going to utilize the MAF transformation curve, it's going to have 25% more fuel added to prevent a lean condition. Okay, so then later on I realized I needed to also modify my virtual volumetric efficiency table. I wanted to add 25% more fuel to that, so that one's pretty simple too. So we're going to go up to the edit. We want to go to virtual volumetric efficiency. So same thing as our MAF transformation curve. What I did is I went to the table, selected everything, and once again 1.25, and then we hit multiply, and then it's going to change these values, and then we're going to calculate the coefficients, and that's on the manifold switch closed. So before clicking on calculate coefficients, after I've increased this table by 1.25, what I would do is go in here and copy all those new values, and then to go to calculate coefficients, and then I'd switch over to the open and do the same thing. You would highlight all this and paste that in there, and then calculate coefficients, or you could once again just highlight everything, put in 1.25 and multiply and calculate. So now I know that I should be in a safe start situation. I've increased the volumetric efficiency by 25%. In terms of fueling, the MAF transformation curve has been increased, the fuel has been increased by 25%, and I've decreased 5 degrees of timing across the entire range. So that way I can start the vehicle up. Obviously I'll have the VCM scanner connected to make sure that I don't have any knock or any other issues going on. Let's see, being that I've changed this vehicle in the past, two things that I have done that we'll be carrying on in these tunes is I have disabled displacement on demand, so I'll be ignoring any type of parameters that deal with DOD, and I've also disabled the catalyst over temperature protection that's on here. So that should basically handle the situation where we're getting ready to the step 3 here. We're getting ready to start. Now once we are complete with the project, we have everything installed, and we're going to actually start the tuning process. Then we're going to get into the normal stuff that I'd focus on with normal tuning. And what I do there, so I have step 4 here. The first thing I'll tackle is dialing in my MAF transformation curve. This will be important definitely in this application because I'll have more air flowing through the system. And then I have a couple of operation modes that I cover when I'm doing this. So I broke that down into different step A's, step B's, all the way to F. So I want to cover cold start operations, warm start, idle, steady state or part throttle, and then full throttle or wide open throttle, and then any of those transient situations. So those in between periods when you're going from a steady state to a power enrichment mode, or anything that's similar to that. And then basically what I have is a README here that just has some notes for me to keep in mind. So this is kind of the method I take when I'm doing all of my tuning. So regardless of if this is MAF or speed, density, or timing, I always do these steps. So the first thing I want to do is I want to disable closed loop, and I want to disable all of my adaptive fuel controls. So basically I don't want any of these adaptive fuel controls to interfere with my tuning process. So that would be your long-term fuel trims. I don't want that interfering. I don't want the computer to make corrections when I'm trying to dial those things in. I want to disable O2 sensors to keep myself in open loop. The DFCO, deceleration fuel cutoff, I want to disable that, so that way it's not interfering. And then something that you probably won't see in other videos, and this is maybe something you don't have to do, but an extra step, and this comes out of, again, the Master EFI Tuner book, is to set all my AFR EQ ratios. And you might be asking, okay, well, what is that? And basically, I guess I'll have to open this up again. We'll go back to our house found file. And I believe it was in fuel, right? Fuel, general, stoic. Yeah. So it's going to be in fuel, general, and this is our stoichiometric. The ideal stoichiometric, if you look at any textbook or look at anything on YouTube or read anything online, the idealistic stoichiometric ratio is 14.7 parts air to 1 part fuel, and obviously, or lambda, 1. And what that means is as you go lean, so as 14.1 begins to increase, so 15 or 14.8 or 15.3, that's going to create a lean conditioning as you go lower in value. So if you get down to 12s, 11s, or 9s, it's going to be richer. Generally going to, so everything with a reciprocating engine like ours, what we're taking advantage of is the PV curves of the gas is expanding. That's the actual work that's being done on the piston and what creates torque in the engine. So if you look at PV curves, you put more heat into that, you're energizing the air particles more, and that's going to expand and create more heat and put more work on the piston and more power. So generally, the leaner you go, the hotter the temperatures, and the more power you can make, with a balance though too, because be careful to knock. You can get too hot where it starts to work against you. So these are, keeping in mind that 14.7 is idealistic. You can see here that for my ECM, the E92 on this Gen 5, it doesn't have 14.7, and this is against percent alcohol. So in my application, I don't this truck doesn't have a flex fuel sensor. It's not flex fuel ready, so I don't use the E85 in here. So everything is 14. For whatever reason, GM decided for this particular L83, and probably for all other L83s in this year and maybe other years, across the board, because it's not E85 capable. It's ignoring this percent alcohol, but across the board they decided instead of 14.7, it's going to be 14.10840. So this is the target stoichiometric value that the ECM is shooting for in its calculations for lambda or AFR, and that's something that we want to know. We want to know what the ECM is actually looking for. So the next thing we can do is we can go over to the fuel. Over into open loop, and these are the different equivalent ratios that GM uses. So instead of using AFR, they use a terminology called equivalent ratios. It's actually pretty easy. It's just the target AFR or the target lambda you're going for versus the desired AFR or lambda you want for, depending on the condition or the operation you're in. So obviously if you're in power enrichment mode, or if you're in wide open throttle or full throttle, you want to go in a rich condition. So I think generally 11 point or 12.5 would be a safe rich AFR for power enrichment to give you enough power, but also let your engine last long. So obviously in a race condition, you're going to go a little bit leaner on that. So what this comes from is just the stoichiometric air-fuel ratio. So that was our 14.1040 divided by what your desired AFR is. For my previous tune, I was targeting 12.5 for this desired APR. Doing some research, I want longevity of this engine. I could go a lot leaner, but I want my engine to last. So I'm going to target 12 AFR. So it's just simple math. If you divide that out, you're going to get this value, and this value is what we call the EQ ratio, or AFR EQ ratio, and that's what these values are here. And so basically, what we're doing is we're going to go into the open loop, and so what we did here, open loop, and this is the EQ ratio for when we're in a gear. And basically what I'm going to do is from around 75 degrees all the way over. So this table is broken out over here on the y-axis in ECT, and the x-axis is IVT. And I'm going to look over here on the ECT axis. I don't have 75, so I'm going to shoot for 71. But basically for this entire range all the way down, so this range, I am going to change this to my calculated AFR EQ ratio 1.1757. So what that's going to do is, if the ECT is this temperature or above, instead of this 1, which essentially be the 14.10840, it's always going to command a 12-to-1 AFR. And again, this is not something that you necessarily need to do, but it just makes it, it's one of those anchor points for me, as I know when I'm watching my my wideband inside ECM scanner, I know that, hey, I'm expecting to see at least a 12-to-1. And if I don't see that, then I know that there's something I need to change. Now, you don't have to do this. There's people out there that don't ever do this and are fine with it, but just the way that I do it. So that's what that's all about. And then the other thing I need to do is, because I am making changes to, the goal of this is for MAF, I need to disable the speed density system. And so that's what these notes are. And then when I'm done, I need to go in and change all these back. So it means I need to re-enable all of my adaptive fuel controls, and then I need to reset my AFR EQ ratios. So that's what I would do for when I'm doing MAF. For speed density, it's pretty much the same thing. So my steps here are the same. Again, cold start all the way to transient. This time, it's going to be the opposite. So this is all going to be the same. I'm still going to disable closed loop, mean open loop all the time. I'm going to still disable all my adaptive fuel controls. I'm going to set up my AFR EQ ratios the same. The only difference is this time I'm going to disable my MAF, and I'm going to be making changes to my to the virtual volumetric efficiency. And then once I'm done, I'm going to change all those back. So that would be step 5. And again, there's videos out there, and we're going to go through this when we get to this part of the tuning. So we're going to show that later on, and there's also a lot of good videos out there from Goat Rope Garage and the tuning school that talks about this. And the last thing is once I get the volumetric efficiency dialed in, the last thing the next thing to tackle would be the timing. Once again, the same steps: cold start all the way to transient, and full throttle, all that stuff. and these are all the same. The only difference here is I'm not doing anything to MAF and I'm not doing anything to the speed density in terms of disabling, but still changing my AFR EQ ratios and still disabling closed loop and the adaptive fuel controls. So this is going to be a little bit of a drawn out process, but it's the steps I like to take to make sure that everything's dialed in. Then the last thing to do once I have got all these guys dialed in, is to work on the virtual torque. And really what the goal is here is I want to make sure, so the Gen 5, the big thing is they're monitoring torque between commanded driver demand and what's actually being applied as a mechanism to control how the performance behaves. And so once we get all these other parameters dialed in, we want to focus on virtual torque and tune that to a state where those controls are not limiting the power output of the vehicle of what I want. I want to get the max out of it, and then you got to stay within boundaries to make sure the ECM doesn't go haywire and start working against you. So that really covers the tune side of the steps I take. And again, we're going to go a lot more details as we start getting into the tuning parts of the process. Logs are logs. They're kind of set up the same way. Again, by vehicle. And again, this is just how I do it. You're welcome to do it however you want to do it. And for me, I'm doing the phase 1 of the LT4 Supercharger. So I kind of break things out a little bit differently here. This is part of this specific project. I have to change out the map sensor. So I wanted to, before I actually take that stuff off and forget about it, I need to go out to I went out to the vehicle and did a log on my stock with the key on, engine off, OEM, the map, so that way I know what to expect currently and what it reads atmospheric without the engine running. And then when I install the new map, I can compare that to this and see how far they're off. So that's what the step 2 this one is here. So normally you wouldn't see this, but I usually break everything down into drives and pulls. So drives is going to be, when I get my initial start, I'm going to be logging that. And when I do my MAF changes, those logs are going to go there. Same with the speed density, timing, and virtual torque. So the other one is the pulls. So this is actually when I use the G-Tech Pro. So these are not steady state, but these are always going to be in power enrichment or wide open throttle or full throttle. And so I'll have that G-Tech Pro set up in the truck, and all the parameters set up to and G-Tech Pro for my particular application. And then when I'm doing my tuning, I'm doing pulls, looking at the logs and making adjustments. So then doing a pull, looking at the logs, taking the logs, making the logs, and making adjustments needed until I get to a point where I feel like I've done the max I can do for ultimate performance. And then repeat the same thing, rinse and repeat for the rest of this for speed density, timing, and virtual torque. And I usually have all those logs and separated out. And so you can kind of see that in the previous project that I did when I was doing the headers and all that. So for my drives, these are all the logs that I've done. So it's just nice for me for myself, again, just how I do it, to keep things organized for me. If I need to go back and change something, or if I need to go back to reference, but you can see, just when you get into speed density, it takes quite a few drives to get things tuned in. I think I'm at wide open throttle in there. So that's pretty much, I think, the majority of what I wanted to cover for, how I organize my tunes and my logs for the different operation modes that I'm targeting. Again, it's just all baby steps. I'm starting all the way from idle all the way to full throttle and just baby stepping through the process. I'm making incremental, iterative changes as I go along until I got the entire thing finished. And this might not work out for most people. They probably don't want to spend as much time as I do to do this, but for me, and it's for me to do. Think I'm to get in dialed into what I want and get the most out of what modifications I've done. This is just one of the methods that I've chosen to go. So yeah, thank you for joining me, and hopefully you've learned something new or at least helped you out. And once again, highly recommend getting this book here. It's only $20, and it is a little bit outdated, but it still has it still does cover. I think it does have a lot of information that you'll be able to get out of it. So thanks again, and I will see you on the next video.